All right, so welcome to College Algebra Section 2.6. It's what we would be discussing. It's about combinations. So this is 3.6, and it's about combinations of functions and also composite functions. Also finding um, the functions, the first thing we'll be discussing is how to find a function's domain. So example one says find, find the domain of the function g of x is equal to 5x divided by x squared minus 49. All right, so to find the domain of this function, we have to make sure that there is no point in the interval of values x that is allowed for this function in which the function becomes undefined. So if there is any x value at which this function g of x becomes undefined, then um, this function, the, then that x value is not included in the domain of this function. If there's any x points at which the function becomes undefined, then that x points cannot be included in the domain. So if we look at the denominator for this function, we have a quadratic form, x squared minus 49. So we can factorize this and we can rewrite this as x squared minus 49 can be factorized as, if we can set it to 0 and solve for x to factorize it. So x squared minus 49 is equal to 0, which means x squared is equal to 49. So if we take square root on both sides, then we have x is equal to the plus or minus square root of 49, which is plus or minus 7. So that means we can factorize this x squared minus 49 as x minus 7 and x plus 7. And if x is equal to 7 or negative 7, then this denominator value here, if x is 7 here, then this part of the denominator will evaluate to 0. And if x is negative 7, then this part of the denominator will evaluate to 0. But we cannot have a 0 at the denominator because the function will be undefined. So we we conclude that the domain of this function g of x would exclude 7 or positive 7 or negative 7 because those make the denominator to be undefined. All right, so let me write that down. So because division by 0 we must exclude them from the domain. But we must exclude them from the domain values of x. We must exclude from the domain values of x that makes the denominator to equal to 0. Domain values of x that makes the denominator equal to 0. Denominator equal to 0. All right, so we can write the domain as excluding 7 and negative 7 from the domain, we can write it as minus infinity to negative. Let me write it on the next page so we can write the domain as minus infinity to negative 7 union negative 7 and 7 and union 7 to positive infinity. So this is how we write the domain of the function. We are excluding 7 and negative 7 from the domain. All right, so let's move on to the algebra of functions. When we look at the sum, difference, sum difference, products, products, and quotients, functions. Okay, so if we said if we let f and g, oh no, so let f and g be two functions. The sum f plus g difference f minus g are products f multiplied by g and the quotients. And the quotient f divided by g are functions whose domains are the set of all real numbers common to the domains of f and g. F and g, which are defined as follows. So one, sum of f plus g is equal to f of x plus g of x. The difference f minus g of x is equal to f of x minus g of x. And 3 with the products f times g of x is equal to f of x times g of x. And for the quotient, the quotient of f divided by g of x is equal to f of x is equal to f of x is equal to f of x. Is equal to f of x divided by g of x. All right, so let's look at some example. So example 2. So it says let f of x equal x minus 5. And g of x equal to x squared minus 1. Determine the domain of the function f of x is equal to x minus 5, g of x squared minus 1. We have to find f plus g, f plus g of x, and we have to determine the domain of this function. All right, so the solution is f plus g of x is equal to f of x plus g of x. So this equals to x my x minus 5 plus x squared minus 1, and this becomes x squared plus x minus 6. Um, and so the domain has no restrictions. There are no denominators. There is no x value in the denominator that would make this function to have a restricted domain, or will make the function to be undefined. So the domain f of x has no restrictions. So the domain of the individual functions f of x has no restrictions, no restrictions. And the domain of g of x also has no restrictions. So has no restrictions. So therefore the domain of f plus c also has no restrictions. Is equal to minus infinity to infinity. It also has no restrictions. All right, so because the individual functions that make up uh, f plus g of x, each of them do not have any restrictions, then the domain of adding them up also has no restrictions, which makes the domain to be negative infinity to positive infinity. All right, so let's look at our composition of functions. The composition of a function the system of the function f with g is denoted f. Uh, this sign is the how we denote the composition of a function and is defined by the equation. Okay. All right. So the domain of the composite function, um, the domain of the composite function f of g is the set of all x such that x is in the domain of f. All right, so let me write that down. Um, the domain of the composite function f of g is the set of all x such that is the set of all x such that x is in the domain of g um, and um, and g is in the domain of f. X is in the domain of g um, and also in the domain of f. All right, so let's use an example to illustrate this. So this will be our example 3. Example 3 says given f of x is equal to 5x plus 6. Given f of x is equal to 5x plus 6 and g of x is equal to 2x squared minus x minus 1. Find find f of g of x and domain. Okay, so f composition of g um, so f composition f of g of x or f composition of g is the same as f of g of x. So that means the x in f is replaced by g of x. And so this is equal to f of g of x, which is 2x squared minus x minus 1. And so this becomes uh, f of x is 5x, so this becomes 5 times 2x squared minus x minus 1 plus 6. And this equals to 5 times 2x squared is 10x squared. 5 times negative x is negative 5x. 5 times negative 1 is negative 5. and this plus 6. So this becomes 5x squared, no, 10x squared rather. This becomes 10x squared minus 5x plus 1. There are no restrictions on this function f of g of x. So the domain is for all real numbers. So the domain of this will be for all real numbers. Or minus infinity to positive infinity. All right, so let's look at another example also on composition of functions. So example 4. And it says find, it says given f of x is equal to 4 divided by x plus 2. And g of x is 1 divided by x. Find to find f of g of x. And f of g of x. All right, so f of g of x and also the domain. So f of g of x is equal to um, f of g of x, which equals to f of g of x is 1 over x. So f of g of x is f of 1 over x, 1 divided by x. And this equals to f is 4 divided by x plus 2. So this is 4 divided by x plus 2, and x now 1 divided by x, so 1 divided by x plus 2. And this becomes 4 divided by, if we take the LCM of the denominator term, the denominator is x. X divides x one time, and 1 times 1 is 1, plus the denominator of 2 here can be taken as, because there is no number, it can be taken as 1. So 1 divides x, x times 2 is 2x. So um, this becomes 4. This becomes 4. And times, if we change the division here to multiplication, we reverse the order of the fraction of the denominator. So this becomes 4 times x divided by 1 plus 2x. And so this gives us 4x divided by 1 plus 2x. So this is f of g of x. Okay, so now let's look at how we can determine the domain. So for g of x, x cannot be 0. because if x is 0, we get 1 divided by 0, which is undefined. So for g of x, x cannot be 0. And for f of g of x, we have, which is 1 divided by 1 plus 2x. Which is 1 divided by 1 plus 2x. We have, if x is equal to negative 1/2, then the denominator will be 0. So from here, if we have 1 plus 2x is equal to 0, and we subtract 1 on both sides, so 2x is equal to negative 1, and divide both sides by 2. So if x is equal to negative 1/2, the denominator will be 0. So x cannot be equal to negative 1/2. So for this, we cannot have x to be equal to negative 1/2. Otherwise, the denominator is also equal to, the denominator will be equal to 0. So to the domain f of g of x will be equal to, so the domain of f domain of f of g of x is minus infinity to negative 1/2 union negative 1/2, and 0 cannot be part of the domain, and union 0 to infinity. So this becomes the domain. So this, I'm going to write it again. So the domain is negative infinity to negative 1/2, and this union negative 1/2, and this union 0 to infinity. All right, so this becomes the domain of f of g of x. All right, so let's look at another example where we express functions as compositions of uh, each other of 2. So this would be our example 5. And it says express h of x as a composition express h of x as a composition of 2 functions, and h of x is equal to square root of x squared plus 5. So express h of x as a composition of 2 functions, x squared, square root of x squared plus 5. So here we have to come up with 2 functions that we can find its composition that will result in x squared plus 5. So if we let f of x, to be equal to the square root of x and g of x to be equal to x squared plus 5. Then f of g of x, we can say, well, h of x is equal to the composition of f of g of x, because which is equal to f of g of x, because this is equal to f of g of x is equal to f of g, so f of x squared plus 5, and f is square root of x, so this is equal to the square root of x squared plus 5. So if we let g of x, f of x is equal to square root of x, and g of x is equal to x squared plus 5, uh, the composition of f of g of x will give us h of x. All right, so let's look at some other examples. So this is example 1a. So this is something related to the example we looked at in example 1. So it says for which values of x, for which values of x is the radical expression, the radical a real number. For which values of x is a radical expression a real number. And the radical expression is the square root of negative 12 plus 2x. So for the radical expression to be a real number, then the numbers under the square root sign should be 0 or more. So if we say negative 12 plus 2x should be, for any value of x, negative 12 plus 2x should be greater than or equal to 0. All right, so now if we add 12 on both sides, we have 2x is greater than or equal to negative 12. And if we divide both sides by 2, then we'll have x is greater than or equal to 6. So the values of x for which the radical expression will be a real number will be x is greater than or equal to 6. All right, so let's look at also example 1b. Example 1b says f of x is equal to 6 divided by x minus 9 plus 5 divided by x minus 7. All right, so as we saw earlier, if x is equal to 9, the denominator here will evaluate to 0. Or if x is equal to 7, the denominator here will also evaluate to 0, which will make the function to be undefined. So the domain has a restriction on 7 and 9. 7 and 9 cannot be part of the domain. So the domain of this function is from minus infinity to 7, and union 7 to 9, and union 9 to infinity. All right, so this cannot be part of the domain. All right, let's look at another example. 1C. So example 1C, and it says find the domain of f of x is equal to 1 divided by square root of x minus 12. So the domain cannot include values of x that make the denominator to be less than 0. So to find the domain, x minus 12 should be greater than or equal to 0, which means x should be greater than or equal to 12. So the domain will be values of x greater than 12 to infinity. So the domain will be 12 to infinity. There should be the values that make the denominator to be either 0 or greater. Okay, so let's look at our last example. This is example 4b. And it says f of x is equal to 3 divided by x, and g of x is equal to, is also equal to 3 divided by x. Find the following. A, f of g of x. F of g of x is equal to f g of x, which is equal to f of 3 divided by x, which is equal to 3. F of x is also 3 of x, which is equal to 3 divided by x, which is 3 times x divided by 3, which gives us x, and b, f of g of 5, f of g of 5, f of g of 5 is equal to, we already found f of g of x, which is x. So f of g of 5 will be equal to x. In place of x, we substitute 5. So f of g of x will be equal to 5. And if we do the other way around, see if we find g of f of x. So this is also equal to g of f of x, which is also g is 3 divided by x, so 3. So this would be g. So this would be g of 3 divided by x, which is equal to g is 3 over x, so 3 divided by 3 divided by x, which is 3 times x divided by 3, which also gives x. So the g of f of 5 is also equal to 5, because g of f of x is x. So g of f of 5 is equal to 5. All right. All right. So this is where we will bring our discussion on section 2.6 to an end, and we'll see you in the next one.